Yesterday, we did the beginnings of transformations, right? For your warm-up, we talked about steepness. What part of a linear equation determines steepness? The slope. So your steepness is determined by your slope. We also shifted up and down. What determines those shifts up and down? The y-intercept. And we talked generically about reflections, right? We didn't talk about reflecting over x versus y, which we will do today. But we talked about reflections and what happened with reflections. Okay, you flip the sign, right? So reflect dealt with the sign. All right. So today we're going to do the rules, the laws, function notation rules. Everybody remember function notation? F of x is the same as y. Input is x, output is f of x in its entirety. So we're going to start with vertical rules, meaning shifting up and down, and reflecting over x, and changing my slope and my y-intercept to then stretch and compress my lines. So this table is kind of a cheat sheet for how the rules are applied. But we're going to practice each one using a baseline function of 2x plus 3. So first thing we're going to do on these first two graphs, graph 2x plus 3. Okay? So here's our baseline, 2x plus 3. I'm going to shift up 2 units first. Now we did shifting up and down yesterday, so it's a good place for us to start with the rules. Anything that happens vertically is going to happen, we say, outside of the parentheses. And what that means is just it's happening to the entire function, not just x. Because if you're talking about vertical, which axis is the vertical axis? The y. The y, which is the entire function, the entire f of x. Good. So if I'm shifting up, based on what we talked about yesterday, what's changing? The y-intercept. But there's a rule that goes along with it. You're going to say f of x plus 2, because you are adding 2 to your function. So when I ask for a function notation rule, nowhere in this rule do you see 2x plus 3, do you? No, right? It's just f of x plus 2, which means that I can plug any function in here and it would work. But for us, I'm going to replace f of x with 2x plus 3, and then I'm going to add 2 to the whole thing. So then what's my new linear equation? 2x plus 5. That's true. Okay, so if I'm going to shift down 5 units, what am I going to do to my function? If I added 2 to the last one, what am I going to do to this one? Subtract 5. So I'm going to, for my rule, that would work for any function, f of x minus 5. And then we apply the rule by replacing f of x with, what's our function? 2x plus 5 plus 3. So when I simplify that, what's my new function? 2x minus 2. And it should be 5 units lower than my previous function. What did I do wrong there? Oh, that's right. far, so good? Yeah, all I'm doing is adding in the rule. So there will be times if I say write the function notation rule, you're looking at this, not necessarily this. Okay, flip it over. Let's get into things that are a little bit more than what we did yesterday. So again, still using that base function f of x equals 2x plus 3. We need to graph it on all of our graphs for this page. Yesterday we just talked about reflections, right? But today we're going to separate reflecting over x versus reflecting over y. Everything we did yesterday was just a reflection over y. So if I'm talking about reflecting over x,
There we go.
I'm going to be taking my line and I'm going to flip it across the x-axis. So when I flip it, what changes? The slope and the y-intercept. Because I'm flipping across x, right? Y'all see the shadow? So not just the x, but also the y. Because my rule for this is that I'm changing signs, right? But outside of the parentheses, negative f of x, or it could be written as negative f of x. Same thing. So when I replace my function, what is my function?
2x plus 3.
2x plus 3. I'm using my original one. Okay? And then I apply the rule. What's negative 2x minus 3.
Would they ever share the same point somewhere?
They share the x-intercept. That only works if you're only doing one transformation though. If I said reflect it over the x and then shift it, it won't share that x-intercept anymore. Okay. Vertical stretch. I'm stretching something. Like anybody ever have silly putty? You stretch it? Or slime? Right? I'm not there. Taking my line. If I'm vertically stretching something, let's say you had some slime or silly putty or whatever, you're vertically stretching it, you're pulling it from top to what? Bottom. So if I take my line and I pull it from top to bottom, what starts to happen? It's steeper. It's steeper. I'm taking my line and I'm pulling it, but not only is it getting steeper, my y-intercept is also increasing as well. So I'm stretching by a factor of 3, which means that I'm going to take my function, f of x, and I'm going to multiply the entire thing by 3. So not only is my slope 3 times larger, what else is 3 times larger? The y-intercept. The y-intercept. So I replace f of x with my function, which is 2x plus 3, and I multiply the whole thing by 3, giving me 6x plus 9. Next thing, which is related, vertically compressing something. What does it mean to compress? You squish it, right? So if I squish my line from top to bottom, what's happening? Flatter. And my y-intercept will then decrease. So I'm taking my function, f of x, and I'm multiplying it by a factor of 1/4 to flatten it. So replace your function with your own 2x plus 3 and apply the 1/4. So now what is my new function? Plus 3/4. 3/4 isn't bad. You smooshed it. You smooshed the line. So as y'all are graphing, thinking about looking back at all of these rules that I applied, everything that I did happened outside of f of x, right? I either multiplied the entire f of x, I added to it, I changed the sign of it. Everything happened outside. So when we flip over to horizontal, now I'm changing gears a little bit, because horizontal, when I think about the axis that's horizontal, I'm looking at x, right? Everything's happening directly to x inside your parentheses. So we're going to start with a different function this time. We're going to start with 3x minus 1. So take a second and graph 3x minus 1 on our first two, then when we get to the back, we're going to shift left and right. So left and right is kind of tricky. So let's just take a second. I've drawn an additional purple line, and we're going to shift it left and right by hand. But you're writing your equation in slope-intercept form, right? Slope-intercept form has the slope and what else? The y-intercept. So when you think about shifting something left and right and then writing it in slope-intercept form, I can't just change one of those values, can I? No, but if I look at shifting something, I'm going left 4 units. If I look at shifting it left, what else is happening?
X-intercept change.
Okay, the x-intercept is changing, but is that part of the y-intercept is changing? What's happening to the y-intercept?
Increase.
It's increasing. So while I'm moving to the left, my y-intercept is also increasing. So here's where I'm going with that. Your initial go-to when you talk about shifting left would be subtraction, wouldn't it? Yeah, because we've always associated left with subtraction. But if I'm increasing my y-intercept, I'm actually going to be adding. So my rule is f of x plus 4. So see how that's different from vertical? Now it's just applying to x, not to the entire thing. It's inside the parentheses. So as I replace my original function into the rule, 3x minus 1, the only part that's going to change is where I see x. And I'm going to build the rest of my function around it. So what do I have to do with this now? Distribute. So 3x plus 12 minus 1. What's my new function? 3x plus 11. Okay. once you graph it, just compare one of the points from the original to the new. How far apart are they? 4 units. So I've shifted to the left 4, but because I'm in slope-intercept form, I have to somehow relate that back to the y-intercept, right? Because how much should I actually go up?
A lot more than 4.
Well, how
7.
much to be specific? From -1 to 11.
So 12.
12. Well, what's 12 divided by your slope? Okay, which is what we wanted to know to begin with. So those left and right happen in parentheses, but they're kind of backwards. So now let's look at shifting to the right. So
What did you just do? Cross forward? Right forward?
if I'm shifting to the right 2, going to the right does what to that y-intercept? It decreases it. So even though I'm going right, I think positive, but it's going to be f of x minus 2. So you're going to build your function around that change of x. So 3 minus 1. Are y'all seeing the difference between inside and outside the parentheses? Okay. Distribute the 3. 3x.
Minus 6 minus 1.
So then that would be 3x minus 7. Bingo. I did something wrong.
Yeah, you only went up by 2 units here, yes.
Ah, thank you.
You did it again.
Oh. Yes. Okay. Flip it on over. We've got to graph 3x minus 1 a few more times. I'm going to reflect over the y-axis. So I'm flipping over the y-axis. What's changing?
X intercept and
Just
slope.
x-intercept and slope. Does the y-intercept change?
No.
No. So my function rule for this would be f of negative x. Not to be confused with the vertical one. See the difference? This one is only affecting x, which will only affect your slope. Vertical will affect the entire thing, including your y-intercept. Okay, f of x, negative x. Bring this down and build your function around it. So what's my new equation?
Negative 3x minus 1.
There you go. I hear y'all whispering. Don't be afraid. Worst case scenario, you're wrong. It's not the end of the world. Okay. Before we talk about horizontal stretch and compression, there's a typo. This should be 1/3, and this should be 2. So go ahead and swap those. A little swapping action. Because horizontal stretch and compression have the opposite effects as the vertical ones. Because horizontally is from the sides, right? So if I'm horizontally stretching, imagine pulling your slime this direction, right? as you start to pull the line, what happens? It flattens. Flat. So, let's see. Your function notation rule, given 1/3, is f of 1/3 x. Yes.
What is the A for? Like the A?
A would be 1/3. It's just the factor at which you're doing it. You're not asked for the factor when you have a quiz or a test. So I'm focusing today more on just the rules. Okay. Apply. Bring this down. Build your function around it. So after I multiply, what is my new equation? X minus 1. Let's see. Okay, horizontally compressed by 2. You're squishing from the sides. Y'all seen that Star Wars movie where they get stuck in the trash compactor?
Use the pole.
You know what I'm talking about? Yeah, or anything where somebody gets stuck where the walls are closing in from the sides.
Oh, escape rooms.
Okay, there you go. Fabulous. The walls are closing in from the side, and what happens to the line?
It starts like
It's going steeper. Good. So, f of 2x. Everything horizontal is inside. So, bring it down and build around. So now my equation is
6x minus 1.
very good. 6x minus 1. Your y-intercept has not changed. You're just squishing it from the side. All right. Y'all want to try to identify some rules? Yeah. Okay. So, I've got a list of rules. We're going to go through this together. First thing we're going to do, round 1, just horizontal or vertical. Okay? So, how do I determine the difference between horizontal and vertical? Nicholas?
Is the function or the thing is in the parentheses of the x.
Very good. Inside parentheses is
Horizontal.
horizontal. Outside is
Vertical.
vertical. So, first one,
Vertical.
vertical. The 2 is outside.
Vertical. Horizontal. Horizontal. Vertical. Horizontal. Horizontal.
Very good. Now let's get a little bit more specific. Okay, this is vertical, but it's a vertical what?
Vertical
Stretch. Good. Vertical shift. Which direction?
Up. Left.
Vertical shift. Vertical shift.
Right. Up.
Up. Up. Y'all, vertical, the only directions you can go, up and down. Left and right would be what kind? Horizontal. Okay. Horizontal what? Reflect over which axis? The Y.
I told you.
We think about horizontal and we immediately go to X, right? But we're reflecting horizontally, which means that we're reflecting over Y. Okay. Next one, vertical. That was a stretch. So that will be a compression. It gets smaller. Flat. Flat line. Okay. Horizontal what? Shift.
Yeah.
Right. Negative. Yep. Horizontal. Opposite.
No, it's opposite. So it'll be
Stretch. Very good. Okay? Get out a device. We're gonna have to move quick, but y'all are gonna practice without me with some partners.